Today, we look at the nomenclature of a family of organic compounds that is known as carboxylic acids. First and foremost, what do we mean by the word carboxylic acids? Carboxylic acids refers to a homologous series of organic compounds that bears the carboxylic group as a functional group. Mind you, the carboxylic group has been displayed. Now, the general formula of a carboxylic acid is also as displayed there. By basing on the general formula of the carboxylic acid, when R is hydrogen, then we have a carboxylic acid displayed there, which is commonly known as formic acid. And also, when R is a methyl group, then we have the carboxylic acid displayed there, which is commonly known as acetic acid. Now, the two names, formic acid and acetic acid, are trivial names, and we therefore do not concern ourselves with their origin, but we are rather interested in knowing how to correctly name all carboxylic acids by basing on Iupac guidelines. So, what does Iupac tell us on the guidelines of naming our homologous series here of carboxylic acids? First and foremost is that as a general rule from Iupac, or as a general guideline from Iupac, the name of the carboxylic acid is always derived from the name of the corresponding alkane. Mind you, when we say corresponding alkane, we mean or we imply an alkane with an equal number of carbon atoms as a carboxylic acid. So the guideline states in plain language that the name of the carboxylic acid is derived from the name of the corresponding alkane by replacing the letter E in the name of the alkane with the letters OIC, followed by a separate word acid. So the table below shows the first 10 straight chain carboxylic acids and their corresponding Iupac names. Now, as you observe the table, try to see the relationship between the name of the carboxylic acid and the corresponding Iupac name of the alkane. It is also possible that you can have the carboxylic group attached to a cyclic chain. And in this case, the format for naming such a compound is as displayed. We shall use that format. The displayed compound there, according to the format, is therefore cyclobutane carboxylic acid. Notice that in all the above parts that we have so far looked at, we have been looking at carboxylic acids that do not have substituents. If you have an alkyl substituted carboxylic acid, then the Iupac guidelines for naming such a carboxylic acid are as follows. First guideline is that you must obtain the parent chain. And the parent chain, in this case, is the longest carbon chain in the compound that must bear the carboxylic group. We shall practice this severally, like we have done in the previous parts of nomenclature. Second guideline states that we must assign numbers to the parent chain obtained in the previous step by strictly starting from the carboxylic group. Why? It is because our carboxylic group is the functional group of the compound. The third guideline is that in case you have more than one similar alkyl substituents on the carboxylic acid carbon chain, then always indicate these similar alkyl substituents by using di for 2 similar alkyl substituents, tri for 3 similar alkyl substituents, tetra for 4 similar alkyl substituents, and so on, like previously studied. And finally, presence of more than one but different alkyl substituents on the carboxylic acid is indicated by writing the alkyl substituents in order of their alphabetical superiority. By using the guidelines stated above, let us try to obtain the correct Iupac name for each of the following compounds there. On careful observation of the compound, you find out that the parent chain is the one that is under yellow highlight, since it has the highest number of carbon atoms, and those are 6 carbon atoms. And this implies that our parent name for the compound is going to be hexanoic acid. The second guideline directs us to number carbon atoms on the parent chain by starting from the carboxyl group. Now, this one has been done as displayed there. After numbering, we identify that on position 3 of the carbon chain, there are 2 substituents, and on position number 4, there is 1 substituent. These substituents must be written in order of alphabetical arrangement, and therefore the name of the displayed compound is going to be 3, 3 hyphen dicyclopropyl hyphen 4 hyphen ethyl hexanoic acid. The second compound displayed there is a cyclic derivative of a carboxylic acid. Now, that cyclic ring is generally taken as the parent chain, and for that case, our parent name is going to be cyclohexane carboxylic acid. After determining our parent name, and for that case the parent chain, we proceed and assign numbers to carbon atoms on the parent chain. But now we should be careful. As we number our carbon atoms, we must make sure that we start from the carbon atom that is attached to the carboxyl group, and also the direction of numbering, that is either clockwise or anti-clockwise, must be in such a way that the 2 substituents that are attached on our cyclic compound are assigned the lowest numbers possible. Therefore, by numbering in the clockwise direction, we identify that the 2 different alkyl substituents are on position 2 and position 3 of the cyclic compound. At this point, we are therefore able to write down the name of our compound as 2 hyphen methyl hyphen 3 hyphen secondary hyphen propyl cyclohexane carboxylic acid. At this point, I welcome you to our live chemistry classroom, where we shall have a chance to physically name a given compound. Welcome to the classroom. And before us, we have a question where we are strictly supposed to name the following compounds. Now, when they say that you are naming compounds, automatically you are supposed and you must follow what we call Iupac guidelines, like we have seen above. So what does Iupac guide us to do in naming this compound? According to Iupac, the first procedure is that from our compound here, we determine the parent chain. And as I have advised you severally, is that before determining the parent chain, always transverse the given compound and obtain all the possible carbon-to-carbon connections. And from those carbon-carbon connections, the carbon-carbon connection that has the highest number of carbon atoms, and if for this case is even attached to a functional group, becomes the parent chain. Without wasting time, this is our parent chain that I have encircled in red. And why is it the parent chain? It is the parent chain because in this compound, it is the longest carbon-carbon skeleton with a total of 1, 2, 3, 4, 5, 6, 7, 8. Now, since it has 8 carbon atoms, we also identify that our parent name is therefore octanoic acid. So that becomes our first guideline. The second guideline is that after obtaining the parent chain, we assign numbers to carbon atoms on our parent chain. But we should strictly start from the functional group. So by starting from the functional group, these are the numbers 1, 2, 3, 4, 5, 6, 7, and finally 8. After assigning numbers, the numbers 6, also 5, 4, and finally 2 are of specific interest. Why? Because on these positions, the carbon atoms have substituents, and the substituents that there are, we have seen previously that this type of substituent is simply an ethyl group, and so is this. We have also seen that this substituent has two names. The first name is secondary propyl, but it can also be isopropyl. And finally, we have also seen that this substituent is simply a methyl group. After identifying our substituents, we must write the substituents in alphabetical order, and at this step, we can therefore write the name of our compound as on position 2 and position 4. There are two similar ethyl substituents, so it becomes diethyl, and then this and this, depending on the name that you use, is that 6-methyl precedes or is alphabetically superior to 5-secondary propyl. At this point, we have already written all the names of the substituents. What is remaining is the parent name, which we said from here is octanoic followed by the word acid. Now this compound has two names because of this and that one. So the other name, which is also correct, is 2,4 diethyl, and then we come to 5-isopropyl, since this is alphabetically superior to the methyl group. And then finally, the parent name. The parent name is octanoic acid. As simple as that. For matters of emphasis, let me encircle our names in blue ink so that it becomes distinct to everyone watching. Part B here, we also are supposed to name our compound. As the rules direct us, we are supposed to determine the parent chain. But in this case, the parent chain is this cyclic ring of 5 carbon atoms attached to the carboxylic group. And without wasting time, we can state without fear or favor that the parent chain is cyclopentane carboxylic acid. After obtaining our parent chain, the next step or guideline mandates us to number our carbon atoms on this cyclic chain. And when we are numbering, remember it can always be anti-clockwise or clockwise, depending on the direction that gives these two substituents numbers that are closer to each other. So that being said, if we are to number in the clockwise direction, these two substituents are going to be very much closer to each other than in the anti-clockwise direction. Now, after numbering, we establish that position 2 and position 3 are of significance since they do have substituents. And by the way, the substituent here is known as methyl, while this one has two names. It can be neobutyl, but it can also be tertiary butyl. So after establishing our two substituents, we now write down the name of the compound as 3-methyl, and then on position 2, at this point we have already written down the names of the alkyl substituents. Now what is remaining is the parent chain. The parent chain is cyclopentane carboxylic The other name of the compound, since there are two names here, can also be 3. As simple as that. In order to put some emphasis, I will encircle these two names in blue ink. At this point, I thank you for being part of my presentation. Do you have any other challenging concept as regards organic chemistry, please contact me via email using the email address in the description of this video, and I will humbly respond to you. Until next time, I remain yours, your chemistry teacher. Goodbye.